Hello again. In this video, I'm going to go over this homework problem from section 3.4. Now, in this problem, we've got two parts. The first part says, find the equation of the secant line through the points x equals 3 and x equals 5 for this particular function. So let's talk about that one first, part A. Okay, so the first thing we're going to have to do is find the slope of the secant line that goes through these 2 points. And if you remember, there's a formula to find the slope of a secant line. And it's f of b minus f of a divided by b minus a. Now, it doesn't matter which one you call a and which one you call b, so I'm just going to call this one a and this one b. So that's just going to give us f evaluated at 5 minus f evaluated at 3 divided by 5 minus 3. Okay, now let's find f of 5 over here. So, of course, you have to plug 5 into here and into here, so that's going to give you 5 squared plus 5, which is equal to 30. Then f of 3 is going to be 3 squared plus 3, right, which gives you 12. And so this is going to give us 30 minus 12 divided by 2, which is just 18 over 2, and that's equal to 9. Okay, so this is the slope of the secant line that goes through these 2 points. Now, we're supposed to find the equation of the secant line, and now that we have the slope, we just need 1 point on the secant line, x1, y1. Okay, we're going to use the point slope formula to find the equation of the line. Okay, so we've got the slope is 9. Now we just need a point x1, comma y1, a point on the line. And there's actually 2 points that we know on this line, right? We have this one here, and we have this one here. In fact, it's actually 3 comma 12 and 5 comma 30. Those are the ordered pairs that we know are on the line. Okay, and we know that because when you plug a 3 in, you get a 12 out. When you plug a 5 in, you get a 30 out. So you can use either one for x1, y1. I'm just going to use this one for x1, y1. Okay, so we get x1 is 3, right, and then y1 is 12. So you just plug those in here. And then let's go ahead and just solve for y here. So let's distribute the 9. So we get 9x minus 27. Then I'm going to go ahead and add the 12 to both sides. So we end up with y is equal to 9x minus 15. Okay, so that's the equation of the secant line that goes through these 2 points. Now, if you look at this graphically, you can go to Desmos.com and graph the equation of the original function, which is x squared plus x. That's this red parabola here. And then you can also graph the secant line, which is 9x minus 15, and that's this blue line right here. And notice that the blue line does go through the point x equals 3, comma 12, and the other point it has to go through is 5, comma 30. Okay, so that is the equation of the secant line that goes through those 2 points. Okay, so let's look at part B now. So what's different about part B is now we're supposed to find the equation of the tangent line that goes through, or tangent to this function that goes through this particular point x is equal to 3, not 5. Okay, they say for the first one, so when x is equal to 3. You could find the equation of the tangent line that goes through x equals 5, but that would be a different problem. In this problem, they want you to find it at the point x is equal to 3. By the way, tangent lines only go through 1 point on the function, whereas secant lines go through 2 points on the function. Okay, so again, the first thing we're going to have to do here is find the slope of the tangent line, which is given by this formula. Right? It's equal to this limit. Okay, so in this case, A is the point that we're finding the tangent line at. We're finding it at 3. So A is 3 here. So this is f evaluated at 3 plus h minus f evaluated at 3. And then we have to divide that by h and then find the limit of that as h goes to 0. Okay, so the first thing I'm going to do here is let's go ahead and find out what f evaluated at 3 is, and then we'll find f evaluated at 3 plus h. So let's find f evaluated at 3. Remember, we've already found this. That just means you've got to put a 3 in here and a 3 in here. One way you can think about this is, what does this function do to any number that you plug into it? Well, it's going to square the number and then add that to the number that you plugged into it. So it takes the number that you plugged in, the input, and it squares it, and then it adds it to the thing that you put into it, which was a 3. And that's why we got a 12 out. So we know this is equal to 12. Now, we need to find f evaluated at 3 plus h, which is a little bit harder. But if you're careful about how you think about this, remember, the input, right? That's your input. We're calling it x. What does this function do to whatever you put into it, right? The input. It takes the input and it squares it, and then it adds it to that same input. That's what this function does to the thing that you put into it. Well, what are you putting into it now? Well, you're putting in 3 plus h. So it's going to take 3 plus h and square it, and then it's just going to add that to 3 plus h. Okay, so that's what you get out when you plug in 3 plus h into this function. Now, of course, we're going to have to FOIL this out. Okay, so first would be 9. Outer would be 3h. Inner would be h times 3. The order in which you multiply doesn't matter. So if you had like 7 times 5, that's the same as 5 times 7. So h times 3 is the same as 3 times h. The order in which you multiply doesn't matter. So I'm going to write it that way so that it's the same as this one. Then the last will be h squared, h times h, plus this 3, and then plus this h. And if you sort of simplify this out, you can see that you've got 7h here plus another h here. Sorry, 6h. 3h here plus 3h here, that's 6h plus another h. So that's going to be 7h's. You have this h squared, which I'm going to put in front. And then you have 9 plus 3, which is 12. Okay, so we can simplify that a little bit. That's what f evaluated at 3 plus h is. It's equal to this. Okay, so I'm going to plug that in there. And then minus f evaluated at 3, which of course is just 12. Now notice that the 12 cancels here. And in fact, these numbers should always cancel when you use this formula. If they don't, then you've done something wrong. Because what has to end up happening is you need to be left with a situation where this top piece has an h in the first part and an h in the second part, so that you can factor the h out. I've got an h here and I've got an h here, right? So I can factor that h out. The reason that's important is because that's going to cancel with the h on the bottom, allowing you to find this limit. Now, if these h's didn't cancel, right? I mean, if prior to canceling these h's, if you use direct substitution to evaluate this limit, notice that you're going to get 0 over 0, and it's indeterminate. But these h's do cancel, and that puts it into this other form. And so when you use direct substitution here, you can actually determine what the limit is. It's actually equal to 7. Okay, so that's the slope of the tangent line at x is equal to 3. Now, the last thing we need to do here is find the equation of the tangent line. So again, we're going to use the point slope formula. So let me erase some of this. This time, the slope of the tangent line instead of the slope of the secant line is what we get for the slope here. And then x1, y1, we don't have a choice like we did before. There's only one point that we know that goes through the tangent line, and it's the point 3, 12, right? Remember the y value was 12 here. So the ordered pair is 3, 12. Okay, and so let's just plug those into the point slope formula and find the equation of the tangent line. Okay, so the slope is 7, and then we have x minus x1, which is 3, and then y minus y1, which is 12. Distribute the 7, so you get 7x minus 21. And then just add 12 to both sides, and you can see that you get y is equal to 7x minus 9. Okay, and that's the equation of your tangent line that goes through this point, 3, 12. Okay, again, I'm going to go to Desmos.com just to kind of give you a picture of this. So this time, this is the equation of the secant line. Now the equation of the tangent line, let me go back and look at it, was 7x minus 9. So let's type that in. And you can see, of course, that's the blue line right here. That's the tangent line. If you zoom in on this, you can see that that line goes through this point 3, 12 right here. 3, 12 right there. And that's the only point that goes through both the function x squared plus x and the tangent line 7x minus 9. It's right there. Okay, so that's how you do the problem. Be careful about the distinction between finding the equation of a secant line versus the equation of a tangent line. They're fundamentally different ideas here, okay? You have to use different formulas to find the slopes of the secant line versus the slope of the tangent line, so make sure you use them in the correct situation. Okay, so I hope you found this video helpful. Thank you for watching. Bye-bye.